sine functions, cosine functions, and tangent functions, these graphs behave very differently than other graphs. They come in like cyclical patterns. So there's a definite cycle that things will go through, and that is how you know whether or not it's a trig graph, is that you will have a cycle. And really that cycle is caused by the whole cycle of the unit circle. So when you think about going around the unit circle, 0 radians, pi over 2 radians, pi radians, and let me get my trusty little bobby pin. Like, you can keep plugging in bigger and bigger angles. So even though we get around a full circle to 2 pi radians, you can keep going past that and do 3 pi radians, but the values just keep repeating. And that's kind of where that cycle comes from, and we'll see that here. It's called periodic data because the length of that cycle is your period. Period equals length of a full cycle. So a periodic function is a function that repeats a pattern of y values at regular intervals. Those regular intervals is the period. That's the length of your cycle. In other words, there's a cycle that gets repeated every x units. The period of a function is the horizontal length of one cycle. So we have period, which we've talked about. There's two other features called the midline, which is the middle. Okay, so there's a maximum and there's a minimum, and then there's a middle, which would be somewhere in between there. And then there's an amplitude. So if you think about your midline, and you think about these as waves, because that's really what they are, if the middle is the midline, the amplitude is how far above the middle this goes, which should also equal how far below it goes. So in this first one, if we were trying to identify the period first, we have to decide where a cycle starts and where a cycle ends. And that can be different for everybody. So let's pretend I'm Jason and he thinks his cycle starts right here at -3. Everyone see that? If I trace along this curve, Jason, tell me where your cycle ends and then begins repeating itself. Wait a second. My cycle's starting here. When is it going to start repeating itself? At right here, one? Like up here. Does everyone see that? That's correct. So if it starts at this maximum, you go down to a minimum and come back up to a maximum, that's your cycle. We could just take that section of the graph and slide it over, and it kind of has repeated itself. Yes? So the way Jason sees it, his is starting at -3, and it's ending at +1, which means his period is how long? How long does that take? How many units? 4. Now, somebody else, let's go to Angie. Angie sees a cycle maybe starting here at 0. So Angie, this starts at 0 and it goes up and over. Tell me when that cycle would stop such that I could start translating it onto itself. So tell me when to stop. Right here. So if I take this section of the graph and just slide it over, does that kind of map onto itself? Not quite. It's a little bit off. You started by increasing, right? You started at 0 and you immediately started increasing. So when am I starting at 0 and immediately increasing again? Should be here. I'm at 0, and then if I take this part of the graph, this section, and slide this starting point over to where we think that cycle ends and just repeat it, it then does become a continuation. Do we follow that? So if you're looking at it in that light, that's starting at 0 and ending at 4, and the period, regardless, is the same. So no matter which way you perceive your cycle starting and ending, and there's lots of different ways to do this, the period's the same for all of you. Okay? So Jason, we did maximum to maximum. Angie, we did like a 0 increasing to the next spot where it was a 0 and then increasing. So kind of like a midline one. And then you could do minimum. Here's a minimum at -1, and then you get back to a minimum at +3. Also a length of cycle of 4. Okay? So there's your period. Your midline is halfway between max and min, aka the middle. So there should be no difference here. The max is at 2. Now max and mins, you look at the y coordinate. So the max is at 2. The minimum is at -2. So my midline is, it's a line, so it has to be y equals. What's halfway between 2 and -2? 0. That's your midline, right here. And so you should, I always draw in my midline with a dotted line. Your amplitude is the height above the midline. Or it could be the height below the midline. Since it's in the middle, it will be the same no matter which way you go. But just to be consistent, we'll do height above the midline. So if my midline is at 0 and my maximum is at 2, what is that height? From 0 to 2? 2. So the amplitude is 2. Okay, really quickly on B. If I start my cycle here, it's going to end over here. That's from 0 to 3. That's a 3-unit long period. Period is 3. My max is at 1. My minimum's at -2. So my midline is y equals, what's halfway between 1 and -2? Nope. -1 would be closer to the bottom than it is to the top. -1/2. And so if I put my dotted line there, the amplitude is going to be how far above that midline is the top point. That's 1.5 units above. So your amplitude is 1.5. Okay? Beneath this, if you look at this picture, this first one, not periodic. Okay? It's got to have a maximum and a minimum. It can't continuously climb like a ladder like that. This one, however, is, and we have, if we do a period, I'm going to go minimum to minimum. Starts at 0, ends at 1, 2, 3, 4. So from 0 to 4 is a period length of 4. The midline is halfway between the max of 2 and the minimum of -1 again. So the max at 2, minimum at -1, which means my midline is y equals 1.5. Or +1/2 rather, not 1.5, just a half. I think drawing it is important because if you put it in the wrong spot numerically and don't really realize it, when you draw it, you're like, wait a minute, that's not in the middle. Like if I had drawn 1.5, that would have been way up here, which is clearly not in the middle of the wave. And then your amplitude is how far above that maximum is the midline. So that's 1 unit down and a half. So it's 1.5 as your amplitude. this idea of frequency that I have not mentioned that word yet. The frequency is the number of cycles you can fit in a given amount of time. So if the period of a function is 4 seconds, so picture this. Something goes up and down, and that takes 4 seconds. So that's 4. And then it goes up and down again, and that's 8. And then it goes up and down again, and that's 12, and so on and so forth. How many of these cycles would we fit in 1 minute? If each cycle is 4 seconds long, how many will fit in 60 seconds? 60 seconds, yeah, Lucas? Divided by 4 second cycles is 15 cycles. That's your frequency in that scenario, because they set the length of time and they say, okay, in 1 minute, what's your frequency? B's interesting. What is the period if you're going to complete 180 cycles in 1 minute? So picture this. Here's your 60 seconds, your 1 minute. I'm going to fit 180 cycles. There's 1. There's 2. There's 3. If I fit 180 cycles, how long does just 1 cycle take? Georgia, do you have a guess? Say it again. 1/3 of a second, exactly. 1 second for 1 cycle would mean 180 seconds. That's too long, right? We have to fit 180 in. So again, we're taking that 60 seconds, like we did before, we're dividing it by how many seconds to get 180 cycles. And it's actually 1/3 of a second is your period. Okie doke. So it can be tricky like that because your cycles can be like a fraction of a second. And you have to, have a decent number sense to wrap your head around that. So we'll stop there. Your homework is